So a couple of reminders. Okay, first off, the 4 tests that you're going to be running in this lab that you need to write the procedure for, okay, are the observable properties test, and make sure again that you are very detailed in not only how to do each test, but in also what observations you need to record. All right, so quick reminder of those in case you're writing these down, which you should be. Okay, you want to make observations of color. You want to make observations of color because color will tell you most likely the identities of 3 of the unknown substances. All right, one of the unknown substances is copper 2 sulfate. One of the unknown substances is nickel 2 nitrate, and one of the unknown substances is cobalt 2 chloride. All right, will you be able to identify those with fair certainty right off the bat with this test? Yes, because their color is indicative of what they are. All right. Record the state of matter, solid, liquid, or gas, and also the nature of that matter. So is it a crystalline solid? If it's a crystalline solid, then it is most likely what kind of compound? Ionic. Okay, so things to remember. Is it 100% sure it's ionic? No, because sugar is also one of your unknown substances, and it is a crystalline solid at room temperature. You'll have to figure out which one it is based on other tests throughout the lab. Okay, what if you're not sure if it's crystalline? Crush it. Right, okay, in your depression plate that I showed you there on Friday, okay, after you've done the other physical properties tests, okay, you can take the glass stirring rod and just press on it. Okay, and if it crushes down to a powder, okay, or changes shape somehow, okay, then you know that it was a crystalline solid. If it doesn't, okay, then it was probably a molecular compound that was waxy, okay, or something like that. Also make note if it's a liquid, if it's cloudy or clear, okay, and things like that. Odor test, you do the wafting test. Do you do the wafting test when you have all the samples in here at the same time? No, because that's absolutely 100% useless. All right, all of their odors will combine, and all you'll get is a nose full of nothing. Okay, or everything. I suppose everything would be more accurate. All right, how should you do the wafting test? Oh, yes, yes, I see everyone demonstrating the yes, wafting like this, but where should you do it? Okay, where all the samples are. Okay, the large amounts, okay, the source samples. They will be up on the teacher's lab station at the front of the room. Okay, you'll be going up there to get your samples, okay, from the large samples. That's where you should do the wafting test. Do you need to bother wafting the solids? No. None of the solids have an odor that's going to tell you anything about them. Some of them have an odor, but because you're not familiar with them, it isn't something that would be helpful for you to identify them. Okay, so make sure then that you are okay, that you are looking just at the liquids. Okay, the liquids that do have an odor are very characteristic, and they will be very useful, okay, in identifying what the compound is, along with, of course, the conductivity test and all of that. Okay, so that you know, and you'll want to make a note of this as well because it's really important. One of your substances that you are going to get, and it is unknown material D, okay, is already in solution. We cannot get it as a solid. All right, so it is already dissolved in solution. So I don't want you, when you're doing the physical properties test, to go, oh, D is a liquid. D is not a liquid. D is a crystalline solid at room temperature, but it has already been dissolved in water for you. Okay, so material D, when you get to that, I'll remind you on Wednesday, okay, is already dissolved. It's already a solution. Okay. All right, for the solubility test, again, give them detailed instructions. Tell them, how much water they should add, and, if they need to stir. What else do they need to do as soon as they add the water? Right, make sure the thermometer is already in there as you begin to add the water, or you may miss the temperature changes. Okay, the temperature changes are really, really important because this stuff right here is one of your unknown substances. It is ammonium nitrate. How many people have ever used one of those cold packs where you pop the water ballast and bladder and you shake it and it gets cold? The stuff that's in there is ammonium nitrate. Okay, so one of your substances during the solubility test will get cold. Okay, anything containing ammonium usually does that. So that might be something to be aware of, as it's a big juicy hint for that one. Okay, you will also have 2 substances that will increase in temperature. Strong acids and strong bases usually do that. And you knew already ahead of time that you were going to have one strong acid and one strong base in your unknowns. All right, so for the solubility test, you record the dissolving. What are some signs that your material has dissolved? Because we said on Friday, given the amount of water and the amount of material that's going to be in those depression plates, they may not entirely dissolve. So what are some signs they have? Okay, the water may take on the color of the crystal. What if the crystal's not colored? Okay, the crystal should shrink, change shape, get maybe kind of round on the edges as opposed to square. All right, things like that. If a temperature change occurs, is that thing dissolving? Yes, for sure. All right, so things like that to watch for. Are those things you should put in your procedure as things to record and watch for? Yes, okay. In your procedure, when you write the instructions for the solubility test, you don't just say add water to the substance. Add water to the material with the thermometer in place, recording the following things in your chart. Everybody follow? Okay, really important you tell them what to record. Okay, and then you have your conductivity test. Again, you just stick the conductivity tester in there and push the on button and record the number. All right, what do you have to do in between? Rinse. Should you also do that with the thermometer and the stirring rod in the previous test? Yes, you should. Rinse them with distilled water from the wash bottle, something that should also be in your procedure, because otherwise people may assume it's okay to rinse them with tap water. Why is it not okay to do that? Right, tap water conducts electricity. It has ions in it and could contaminate some of your other solutions. All right, so things that need to be in a detailed procedure. And then lastly, the pH test. Remember, we're doing the pH test last because when it happens, a chemical change occurs and then the substance is no longer any good for doing any of the other tests. So what if you do the pH test and then you start to get that uneasy feeling where you might have done something wrong with that material previously? What should you do? Do it again. Yeah, go get a fresh sample. Okay, there's lots, so if you think you need to do a test over again, go get a fresh sample and do it again. All right, don't be afraid to do that. Okay, if you think you've made a mistake, definitely do that. All right, questions on that? Okay, now what your job today is to get your essentially pre-lab activities done. That means write out the problem. What do you have to do with the problem? Put it in your own words in what form? A question, right. Okay, so in your own words in the form of a question, remember that what we're trying to do here is figure out if we can identify substances by their properties. Okay. Your hypothesis. This is the part most people have trouble with. Contains if, and then. Now, hopefully you're listening carefully and writing this part down because it's a big juicy hint for you. All right. The if part deals with the premise that we are working on. The premise we are working on is that all substances have what? Well, no, we can't really test whether they have atoms or not. But they all have their own properties. Those properties are unique to them. That's the premise we're working on. Okay, that all things have their own unique physical properties. That is what needs to be in the if part of your hypothesis. Okay? Because if that's not true, it doesn't matter what we do tomorrow. Or on Wednesday, sorry, everything comes out the same, doesn't it? All right. So that's the premise we're working on. The and part just briefly describes the experiment. Don't go into detail here. You don't have to say that you're doing the following tests. You can just describe it as a battery of tests. That means, a series of tests that are being done. All right. The then part says what you should find or be able to do at the end. What are we hoping to find and be able to do? Right, we should be able to identify the unknown substances because each one will have yeah, but instead of using properties in the then part, we should say that they'll all give us their own unique results, right? Okay, rather than use properties in the if and the then part, we should talk about the results we get. They should each give us their own results, okay? Things like that. That's what goes in the then part. Okay, if you didn't get all that right now, when you're putting the lab report together, should you listen to this? Yes. Okay. Yeah, I'm putting it. That's what the YouTube videos are. The YouTube videos are podcasts. Yes. Okay. All right. Now, for the materials, what do you write? C sheet, so that saves you lots of time. Procedure, that's what we just finished talking about. Step-by-step instructions, detailed, telling them what to record and what to do. Okay? And then, last thing that you should get to today is creating a chart to hold those observations. All right? You have 4 tests that you have to record the observations for. The physical properties test or observable properties test is the biggest one. Make sure that that part of your chart is the largest so that you have lots of room to record things. The pH test and the conductivity test, what do you need to record in there? A number between 1 and 10 for the conductivity and 1 and 14 for the pH test. Those can be very narrow columns. So make sure you leave lots of room for observable properties, quite a bit of room for your solubility test, and then the last 2 can be very small. No, good question. Do I have to write the procedure for every sample? No. I've had people do that in the past, and they hand in this 10-page lab procedure because it says, step 1, substance A, blah, blah, blah. Step 2, substance, or, step 8, substance B, and it's exactly the same thing. Just put repeat steps 3 through 10 or whatever for each substance. Yeah, that'll save you tons of time, and that's what anybody else would do. All right, if you're doing exactly the same steps over again for the next substance, make sure that you say just repeat. Okay, sorry, we skipped over the variables. All right, so back to variables here because that goes after your problem. Manipulated variable. I gave you that on Friday, but we'll quickly review it. What are we changing each time we run the tests? Right, the chemical, the material, okay? Whatever substance it is. We're changing the substance each time we run the battery of tests. Okay? Now, a manipulated variable is just that. It is the thing that is being changed, manipulated, altered, okay, by the experimenter. Make sure that when you identify the variable, you explain why it is the manipulated variable. Okay. If each thing has its own unique properties, what's a responding variable? Right. The results of the tests that we record. Right? They should be different each time we run the tests on a different material. Right? That's what you need to explain in your responding variable when you explain. This is the responding variable because it's doing just that, responding to the fact that we're testing something different. And your controlled variables, you need a minimum of 3, but I would say for this lab, you could probably easily list 5. Okay? The big ones are things like, should you use the same amount of everything? Yeah, because if you don't, that can affect the results of your tests, right? If you put a big pile of copper, 2-sulfate in, and then you put like 1 tiny grain of salt, it's not a fair comparison. Okay, so we have to make sure that we're using the same amount of everything. All right. What about the amount of water used for the solubility test? Is that important? For sure. Okay, tell me why. Just make sure that you list things. You tell me these things need to be the same every time the tests are run because if they aren't, this is what will happen. So tell me if they aren't controlled when you're explaining what will happen if they're not. Okay? Environmental things can be controlled variables. Right? Is solubility affected by temperature? Okay. Think about that as a possible controlled variable. Okay. All right. That should cover it all. Yeah, okay, I think that covers it all. So if you want to get together with your group, remember groups of 3, please. Okay, if anybody is without a group, let me know and I'll put you in one. All right, now, just a note here to be aware of. Each person is handing in their own lab report for this. Okay, that's why each of you has a sheet with your name on it. They do need to be unique. Obviously, if you're working with a group, they're going to be similar. All right, because you're coming up with the hypothesis together, you're coming up with the procedure together. I understand they're going to be similar. What I do not want to see is 4 copies of the exact same file with different names on them. All right, because that says to me somebody did all the work and 2 other somebodies rode on their coattails. All right, that is not right. Each person is going to hand in their own that they typed up, all that kind of stuff. Yes, they're going to be similar, that's fine. But if I'm marking your class, I'll know if I've read 4 of the same report. Okay, and don't just bother changing the font size or font type or whatever, because I can tell if I've read the same thing 4 times. Okay, I'm not senile yet. What was I talking about? Okay, so just make sure that you don't do that. All right, everyone hands in their own. It doesn't take you that long to type it up. Okay. Remember also that you can hand it in to me, or you can bring it in to me, sorry, ahead of time. If you have it done ahead of time, bring it in and have me look it over. What I mean by ahead of time, so that there's no mistaking this. Okay, that means in advance of the due date. So if it's due on Monday, okay, bring it to me on Friday. All right, so you can bring it in ahead of time, but here's the thing, okay? If it's due on Monday, that means you can bring it to me on Friday, you can bring it to me on Thursday in scheduled help or at lunch, okay? Or you can email it to me over the weekend, and I'll try and have a look at it even then, all right? But here's where the kind of line has to be drawn. After 7 o'clock on the night before, I will no longer review them, okay? Because I've had people email them at like 1 in the morning. Mr. Coder, can you please look this over? I'm asleep. I'm old, okay? I'm not staying up till 1 o'clock in the morning. I have little kids who get up early, okay? Well, and I get up early. So I won't look at it then, all right? If you send it to me after 7 o'clock, I'm not reviewing it for you on the night before, because you've obviously left it until the night before, and that's when disaster strikes, so I won't be part of that, all right? You send it to me before that, no problem. I'll look it over and send you back some feedback, all right? So those are your options for getting some review prior. Questions? All right, let's use our time effectively today. This is helping you to avoid a lot of homework later. Yes? All right, something that's come up, and I didn't mention it before, I should have, I just forgot. Something that can save you a lot of time down the road here. Every lab you get from me is going to have the same layout, right? Problem, design, materials, all that kind of stuff. It's always going to go that way. It might be a smart idea if you want to save yourself some time to build a template file for your lab reports. Okay, a lot of people do that, and then they don't have to write out, the repetitive stuff every single time. A way to do that is you can download the lab off of my website and just copy from the PDF into whatever word processing program you use, and just delete the details and save it as your template, and then it'll save you time later. Okay, I mean, the first time you spend a little bit of time, but it's an investment. Each time you do a lab, you don't have to write out, problem. You don't have to put it in the right order. It's already formatted, and it can save you a bunch of time. Okay, so it's an option there if you want to try that.